In this session we shall see the processing of tunnel design project. As the main screen opens, use File menu to select Set Working Folder. Next, select Folder Work located on the desktop. Select Menu Item File, then New/Open Project Workspace, next select New/Open Tunnel Project. Create Project. As the workspace opens, the current selected tab is Create Project. For processing users' data, user needs to click on button Create Project under New Project. The new project is created as Design Job Number 01 inside the project folder created inside the working folder as Work Tunnel Design Projects, Design Job Number 01. Next, user needs to click on button Browse to select the user's total station survey data file. After selecting, a copy of the file will be brought into project folder Design Job Number 1 to process. For processing tutorial example data, user needs to click on button Open Tutorial Example Data. The new project is created as Tutorial Tunnel Design inside the project folder created inside the working folder as Work Tunnel Design Projects, Tutorial Tunnel Design. Here user need not click on button Browse, as a copy of the total station survey data file tunnelsurveydata.txt and also the project data file.txt will be brought into project folder Tutorial Tunnel Design to process. Under New Project, the survey data file is shown with the path. Design of bored tunnel. Design of horizontal alignment of bored tunnel. Select tab, Design of bored tunnel. Under this, the tab Horizontal Alignment is currently opened. The option Process Halon Design Data is selected. Click on button Proceed to create the string M001 under Model Design for the horizontal alignment of the tunnel center line passing through the bottom of the tunnel cross section. To understand the 200 Halon data, user may refer to relevant section of the user's manual or help in the main screen of head site. As the process dialog box comes, click on button Proceed. As the process is over, the message comes about the output report. Click on button OK and click on Finish. Click on buttons View Halon Design, Shenage on and Details on, and the alignment of string M001 under Model Design will be displayed. Design of vertical profile of bored tunnel. Select tab Vertical Profile is currently opened. The option Process via Line Design Data is selected. Click on button Proceed to write proposed design elevations. The string M001 under Model Design is already created by the horizontal alignment of the tunnel center line passing through the bottom of the tunnel cross section. As the process is over, the message comes. Click on button OK and then Finish. To understand the 300 via line data, user may refer to relevant section of the user's manual or help in the main screen of head site. Click on buttons View via line design, Grid on and Vertical Details on, and the profile with elevation of string M001 under Model Design will be displayed as shown below. Design of cross sections of bored tunnel. Select the tab Cross Section under the main tab, Design of bored tunnel. There are two more tabs under Current tab, Define Cross Section and Create Cross Section. The tab Define Cross Section is opened and relevant options are selected with data as marked in the figure below for the tutorial example data, and we will not change the selected items. Next, select the tab Create Cross Section and click the button Process Cross Section Data. As the batch process dialog box comes with list of two processed in sequence, click on button Proceed. As the process starts, the dialog box comes. Click on button Proceed. As the process is over, the message comes. Click on button OK and Finish. The process dialog box comes for the second process and repeat the same actions. Finally, click on button Finish and wait. The entire length of tunnel will be displayed with design and as-built forms. The icons for Rotate 3D, Color Fill and Remove may be used for various views. Next, click on button Tunnel Cut Quantity. As the dialog box comes, click on button Proceed and wait. The window will come with Schenage-wise as-built and design cross-sections and details of as-built and design quantities. User has to wait until the window comes. In the window as shown below, the various controls are marked to be used for viewing the cross-section and the quantity details. Both the windows are used for different views of the cross-section and the quantity details. The robotic total station survey data is very widely used in the construction of bored tunnels. This is to be noted that the survey is carried out after the boring is done for the tunnel, by following the design horizontal alignment, vertical profile, and proposed cross-section for the tunnel. The survey data is used to estimate the actual boring against the design cross-section of the tunnel. At every Schenage, the as-built and design cross-sections are plotted. From the cross-sections, the undercut and overcut quantities are computed by comparing the as-built against the design cross-section. Sometimes in case of excessive overcut, the cut quantity is considered up to certain extent outside the design cross-section, which is marked as the pay line. Proper measures are to be taken to restore all the overcuts and to remove unwanted soil or rock at the undercuts to match the bored cross-sections with the design cross-section. All these actions can be done by using the robotic total station survey data and thus processing by head site to generate cross-sections and quantities for design cut, as-built cut, undercut and overcut, and the pay line, also by creating CAD drawings and detail report. User may use the marked switches to view as desired. Plan, Profile, and Cross-Section Drawings of Bored Tunnel. Select the tab Drawings. Under this there are 3 more tabs. These are Plan, Profile, and Cross-Sections. The tab for Plan is currently selected. Click on button Process Data. As the process dialog box comes, click on button Proceed. As the process is over, the message comes about the output. Click on button OK and finally click on button Finish. The plan drawing is created in the project folder. Select the tab for Profile. Click on button Process Data. As the process dialog box comes, click on button Proceed. As the process is over, the message comes about the output. Click on button OK and finally click on button Finish. The profile drawing is created in the project folder. Select the tab for Cross-Section. Click on button Process Data. As the process is over, the message comes about the output. Click on button OK. Design of tunnel lining. The construction RCC tunnel lining requires design. Design of RCC tunnel lining requires analysis. Analysis of tunnel lining requires structural model. Loading and loading requires data in respect of rock or soil mass to be supported by the tunnel lining. Rock mass rating, RMR, with rock quality designation, RQD, is important to apply rock loading correctly. Select tab Data Input and under it Data Input, various default data are given for every input. User may change the data as desired. Select the tab Computed RMR. Here the calculated values of RMR are displayed. Select the tab Create Data. Some data are displayed in various input boxes which will be required to create the structural model of the tunnel lining to be used for structural analysis. Click on button Create Analysis Input Data. The message comes informing about the analysis input data. Click on button OK. Click on button View Analysis Input Data. the analysis input data opens in Notepad. User may view the data and may take print of the data. There are many tabs related to various aspects of the analysis input data. Select tab Analysis, select tab Pre-process, select tab Geometry. The structural model is displayed. Use various icons for 3D rotated view of the model, to view members, joints or nodes, supports, loading etc. The tab Loading is selected. The list of various loads comes on the left data panel of the workspace. User may modify the values of sections properties, material constants, support, loading as desired. User may save the modified or unchanged analysis input data, by clicking on button Create/Up Data Analysis Input Data. Click on button Process Analysis. As the process dialog box comes, click on button Proceed. The number of load cases used for the structural analysis will be displayed. Click on OK. Next analysis dialog box comes. Click on button Proceed. As process finishes, message comes about analysis report. Click on button OK. The analysis report is displayed for viewing by the user. The report gives member forces for bending moments, torsional forces, shear forces, and axial forces, to be for design. After the analysis process, select tab Post Process, then select tab Load Deflection. The deflected shape of tunnel model under individual load case may be observed. Next, the tab Max Force is selected, which displays each member with the maximum forces picked up from various forces obtained for under various load cases. For the design of RCC tunnel lining, select the tab Design. The default design data is given for every input. User may modify the data as desired. Finally, click on button Proceed. The design will be done. A detailed design report will be opened for viewing and printing. Select the tab Drawings as the final production of the analysis and design. A complete set of drawings with default dimension and structural details are displayed, which are also possible to edit in CAD Engine of Head site for their use in construction as complete deliverable. Coach Profile. Inside the tunnel, when the vehicle travels at curves, there is super elevation or cant. This makes the vehicle tilt towards the inner side at the curve in the tunnel. It is therefore essential to estimate the lateral clearance of the traveling vehicles at curves inside the tunnel. Select tab Horizontal Alignment. The example Halon data is loaded. Click on button Proceed. As the process starts, the dialog box comes. Click on button Proceed. As the process finishes, the message comes. Click on buttons OK and Finish. The horizontal alignment of the tunnel center line is created as string M001 under Model Design in the model files model.fill and model.lst. Click on buttons View Halon Design, Shehnage on and Details on. The horizontal alignment of string M001 with shehnage and curve or intersection point, IP, details are displayed. Select tab Vertical Profile. The example V-Align data is loaded. Click on button Proceed. As the process starts, the dialog box comes. Click on button Proceed. As the process finishes, the message comes. Click on buttons OK and Finish. The vertical profile of the tunnel center line is created in the string M001 under Model Design in the model files model.fill and model.lst. Click on buttons Draw Vertical Profile, Grid on and Vertical Details on. The vertical profile of string M001 with shehnage and vertical curve length and vertical intersection point, VIP, details are displayed. Select the tab Coach Profile Inputs. Data at various inputs are displayed in this page. In new design, user has to enter the data as desired. Here in the dual cell tunnel, 2 coaches of underground metro train, on either side of the tunnel central wall are shown. At each curve the coaches will be tilted towards the inner wall at the curves in the tunnel, and the available lateral clearance is to be checked against the standard specification. Select the tab Process Data, click on button Process Coach Profile Data. The batch process window comes with the list of 4 processes in proper sequence. Click on button Proceed. For each of the 4 processes, every time the process dialog box comes, user has to click on button Proceed. As the process finishes, the message comes. Click on buttons OK and then Finish. As all the 4 processes are over, click on button Finish as shown on the right side of the batch process window. 2 controls are marked in the figure below. Use the marked button may be pressed continuously to view the coach profile at curves, inside the tunnel, the icon for measuring distance may be used to measure the lateral clearance at desired locations. Any particular cross-section can be selected by selecting the shenage. The icons in the top bar are marked as shown in the figure below. Select the tab Design Details, click on button Create/Update Project Data File. The project data file is displayed and the message comes. Click on button OK. Next, click on button View Drawings. This will open Heads CAD Viewer to view the complete set of drawings as created. Heads CAD Viewer is open to view the complete set of drawings as created. At each drawing, 2 cross-sections at a shenage is displayed. User may select a shenage from the list as shown on the left side. The drawings may be printed or saved as DWG or DXF in a desired folder. This is the end of the session for processing of robotic total station survey data along with creating of the alignment, profile, cross-sections, and cut quantities for design and as-built sections of a bored tunnel, tunnel lining and coach profile.